For our next talk, we have the pleasure of two speakers from Panasonic, one who's calling in remote through the OmniLab robot. They will be talking about leveraging generative AI in the food supply chain to improve reliability and security of food supply. So please join me in welcoming Tatsuya Hagiwara, Director of Panasonic China and North Asia Digital AI Development Center, and Zhang Yu, Software Engineer at Panasonic Software Development Center in Dalian.
Thank you for the introduction. I'm Tatsuya Hagiwara. I'm Director of AI and Digital Development Center, Panasonic China and North Asia Company. I would like to thank you to Automatic members for inviting to me talk today. Automatic, we have very good collaboration with Automatic for 4 years. Today, it's very pleasure to talk our challenge for revolutionary cold chain service in China and North Asia with our development team leader, Zhang Yu. Zhang Yu-san, please introduce yourself.
Okay, good afternoon, everyone. I'm a software engineer from Panasonic Software Development Center. My name is Zhang Yu. I'm responsible for the localization and operations of the Panasonic cold chain related AI projects in China. I'm delighted to participate in the Key First World Symposium. Thank you.
My talk consists of following. First, our company introduction with our business area. Second, current status of our cold chain business, such as supermarket. Then, our cold chain business and its main system called Store EMS. Then, now the problem facing Store EMS and its solution. After that, demonstration of the solution with aiVA. Finally, next step and future plan. I'd like to start by talking about our company introduction briefly. Here you can see this is our company introduction. As you know, our Panasonic have a wide range of household appliances that support your lifestyle, such as refrigerator or microwave oven, and so on. Of course, household appliances are an important part of our business, but we are also focusing on business related to the environment and energy saving, right side. For example, one of our factories use fuel cell and solar panel to generate electricity to cover all the factory. In the next slide, I'd like to talk about our business area specific. This is our business area. We are in the industrial and consumer business. In the industrial business, we have smart city, HVAC, such as air conditioning and ventilation, and cold chain. In our company's business area, there are many fields where AI technology can be utilized. But today, I'll talk about the cold chain business. This is one of the areas where AI technology is most extensively utilized in our company. And this is one of the areas, excuse me. The cold chain business includes not only supermarket, but also the refrigerated warehouse and kitchen. Our cold chain business has been operating for many years in the United States, Japan, Oceania, China, and other regions. In the past, Our cold chain product had a strongly market presence with high-quality hardware. However, our current market share has declined. There are several factors lead this, but the main reasons are improvements in competitor product quality and cost competitiveness. Furthermore, to make matters worse, the market size has been slightly decreasing. Therefore, we consider the cold chain service business instead of hardware business to be very important. I believe this is not only our company, but also other industrial leaders in this area in the world. This is an overview of our cold chain business. In service section, optimizing operations and energy efficiency are the primary customer values. The main components of those services is the store EMS. EMS means the energy management system. I'll provide more detailed store EMS later. Due to limited time, I won't go into detail, but our service, AI technology, has been used in the energy saving and predictive maintenance and so on. The store EMS is our system designed for our cold chain service. It includes functions such as facility management, maintenance, remote monitoring, and energy-saving features. So far, it has been installed in thousands of stores in Japan and China. Unfortunately, currently, this service is not available in the US. The system features a store master controller to which various equipment and sensors are connected. Since this product requires installation, so there are several problems to address. This system collects equipment operation data and sensor data, such as temperature and compressor pressure data, uploading to the data to our cloud platform. One of our services, such as predictive maintenance, also utilizes this data on cloud. I'll now introduce the key problem currently we are facing. Number one, the installation maintenance quality level is not stable. This is because the lack of maintenance engineers skill. If the cooling system problem occurs in the store, it damages the food. That's a big problem for our customers. Number two, the high turnover of installation and maintenance employee. So we cannot spend a cost on training maintenance engineers. Number three, upgrading the skill of employee takes long time. This is because those skills requires a lot of expertise. The last one, the knowledge is scattered. In other words, the expertise is often tied to individual engineers, or related documents are not well organized. To solve those problems, we introduced AI advisor to assist the maintenance person. One possible solution is to use generative AI. However, it is not possible to access OpenAI directly from mainland of China. To solve this problem, Automatic help us. Thank you. Currently, we are using domain expertise, technical and maintenance manual, and repair maintenance history to progress with the build AI advisor. We have three main requirements for this AI advisors. It must secure, reliable, and easy. To quick build the system, we are collaborating with Automatic. Automatic has great virtual advisor, aiVA. From the next slide, Mr. Zhang Yu will introduce an overview of this system and provide some demonstrations. Zhang-san, please go ahead.
Let me introduce the aiVA system and provide the demonstrations to you. Okay. First of all, I will introduce the system architecture of aiVA in the EMS system. There are three use cases are shown here: on-site troubleshooting, engineering, training assistant, and the after-sale services. The user interface is designed as a web application, accessible across various platforms, including PCs, mobile services via a web browser. This application primarily features a chat box for natural language interaction with aiVA, along with one or more customizable widgets such as real-time data monitor, visualization, or diagnosis, planning, and retrieval citations and prediction results. Additionally, we provide users with the option to interact with the aiVA at the API level, allowing integration of the core aiVA into the existing applications. Please note that this API integration requires certifications for the securities. Then the aiVA backend. aiVA backend contains three main components: GMMs and SSMs and storage databases. The first, general management model, or GMMs play a central role in handling heuristic information, applying analytical techniques, and provide problem-solving guidance. They orchestrate the flow of questions and problems to the relevant small specialist agents and synthesize response from there. GMMs are used in various applications such as inventory optimization, energy optimization, and maintenance task planning. The second, small specialist agent, or SSA, are expert in specific industrial domains. They are trained to respond to user queries within their designated domains, offering precious knowledges. Whether it's user manual for EMS, or troubleshooting procedures, installation instruction, or predictive maintenance using AI models, SSMs provide tailored and accurate answers based on their domain expertise. Then the storage and the database. Storage is used to securely storing private materials, technical documents, and indexing for SSMs and GMMs. The database serves as a repository for conversation information, communication parameters, and other relevant data. The third part of this aiVA backend is the core LLM. It serves two essential functions. First, natural language middleware. This component handles language-dependent tasks, such as smoothing responses, pre-processing sentences, and extracting relevant information from user input. The second one is long-term experience. The core LM offers long-term and often unchanging expertise, particularly in management and analytical skills. It plays a vital role in swiftly providing guidance from problem-solving functions. These functions are achieved through the fine-tuning process and primarily support the general management models. The core is designed to be modular, so it can separate it from the overall architecture, allowing for easy replacement with different language middleware or SSM. And this flexibility of the core ensure adaptability and efficiency in language processing and knowledge delivery within our system. The architecture has been designed to provide the following key features. The first one, optimization and domain-specific knowledge. The system optimized the utilization of domain-specific knowledge through document indexing and heuristics. This ensures that only relevant domain knowledge is accessed, minimizing the risk of generating inaccurate information. The second, customer ownership and privacy. All data and models can be managed and operated within isolated environments. The LM is replaceable with various language models, and the data indexing and fine-tuned models are securely hosted, whether in an automatic isolated environment or on CNA infrastructures. The third, the support for SSM with fine-tuned SLMs. Many of the SSMs can benefit from the fine-tuned SLMs. This allows the model to provide rapid response and more precise answers, enhancing the overall user experiments.
I will show you guys the demonstration of this aiVA system. The first one is the visual training assistance. In Jiangning Province, China, there are nearly 4 to 6 new convenience stores adopting the EMS system each week. This poses challenges for EMS system deployment. With the assistance of aiVA, it can serve as a training assistant, helping us training new engineering to meet the ever-expanding construction demands. Here first, I will just aiVA as an assistant with expertise in EMS installation and instructions. You are tasked with summarizing a relevant training plan for a group of new installation engineers who will be learning about EMS store, installation, and debugging. Additionally, please highlight which part of this training plan are crucial and should receive more time and attention. Okay? The aiVA gives the answers that which new engineering should receive more time and pay more attention about this. The second demo is about construction site assistance. Due to the complexity of the EMS system, even experienced installation engineers encountered various new challenges and issues during the construction and the installation process. Previously, engineers had to spend a significant amount of time referring construction documents and blueprints to address these challenges. With assistance of aiVA this time, engineers only needed to describe the problem they encountered to aiVA, and it can swiftly provide solutions in the most efficient manner. The first question is how to import a VPN certificate. I think aiVA can answer in both English and Chinese. All the answer is Chinese, but I can ask them with the English. Here's the exact step is how to import a VPN certificate. First step, second, third, and here's the most important part. Yes, how to import this and how to do on a panel when engineering in the onset. Each steps. And the next question is, please tell me how to wear the air conditioner adapters. Okay, here's the answer. How to wear air conditioner adapters, and here's also the reference. I think this is the most important since when the engineering installed a new EMS system. Let's try another questions with Chinese. How to connect the communication cables of the refrigerators. Yes, and the aiVA give the answers and the reference, very important pictures right here. Okay, the last questions. Yeah. Also here, how to control.
The first one, aiVA in Chinese. I think for this aiVA system right now, jargons and terminologies in technical documentations, it is common to encounter various of jargons and terminologies. Engineers and construction workers may use different terms to refer to the same object, and the same concept can be described in multiple ways. Unfortunately, this name are not always standardized in the technical documents from which aiVA was trained. As a result, when asking questions, aiVA can provide answers based on the keywords present in the technical documents. The second is experiment with the different type of knowledge inputs. Certainly organizing and processing the diverse technical documentation, including illustrated materials and various field formats, can be a challenging task. The training document used for aiVA encompass a range of formats, from standard office file types like Word, Excel, and PowerPoint, to the AutoCAD drawings export as PDFs. In order for aiVA to perform better, we need to organize and process these different type of informations. But this requires us have enough industry knowledge to be able to do so. And the third, automate update the knowledge. Because of the complexity of the EMS system and the uncertainty of the construction set, there are many situations that not documented in the technical documentations. At this time, it is necessary to access external data sources, for example, from the engineer's construction record or the maintenance logs and so on, to automatically update aiVA's knowledge base. In this way, aiVA will become more powerful and play even more important role over time. All right, thank you.
I'd like to share our future plan. One, expand the development of aiVA to HVAC operations. Two, automatic as a key technology partner to work with Panasonic China and North Asia company for industrial service. Thank you very much.
All right, maybe I'll ask one question then. How do you get some of the operator buy-in, the engineer buy-in? We talk a lot about the technology and the capabilities of field assistance or troubleshooting support. Have you found what works well to get the engineers who are on the ground bought into the solution?
We get this know-how from the interview from engineers.
And then they start using the solution and adding more knowledge and feedback and starting to get value from it over time.
That's correct.
Great. Well, thank you very much.